In today's video, we are going to learn about implementation of macro processor. In the last video, we have already seen what is a macro, what is macro definition, what is macro expansion, and what is macro call. And also we have seen what are the features of macro facility. In today's class, we are going to study about implementation of macro processor. Before moving on to the implementation of macro processor, we must know what is a macro processor. Macro processor is a program which receives the assembly program which contains macro definitions and macro calls and convert into a program which doesn't contain macros and macro definitions. So the output of the macro processor, which means the program which is not containing any macro, will be given as input to the assembler, and the assembler will generate the equivalent machine language code. So macro processor is the program which takes the assembly program with the macro definitions and macro calls and generate the expanded code without any macros. We'll see what are the steps involved in implementation of macro processor. These are the 4 steps. First one, statement of problem. Second one, database specifications. Third one, specification of database format. And the fourth one, 2-pass or 1-pass algorithm. Statement of problem means if you are going to implement a macro processor, we must know what are the functions to be performed by a macro processor. Those functions has to be mentioned in the first step, that is your statement of problem. In the second step, that is database specifications. In the entire implementation process, if you are using any databases, you have to mention the name and the purposes of the database. That is happening in the second step, that is database specifications. And the third step is specification of database format. If we are using any databases, we have to mention the format of the databases and the size of the each entry in the databases in the third step, that is specification of database format. And the fourth step is the algorithm for implementation. In this particular chapter, we have to study 2 algorithms. The first algorithm will be using 2 passes for the implementation, whereas the another algorithm takes only 1 pass for the implementation. We have to study both the algorithms. Now we'll see in detail about each step. So the first step is, as I mentioned, this is the statement of problem. We have to specify, we have to mention what are the basic functions or tasks to be performed by a macro processor. The basic 4 tasks of a macro processor are: first one, recognize macro definitions, save the definitions, recognize macro calls, and expand macro calls and substitute arguments. What do you mean by recognizing macro definition? How can a macro processor recognize macro definition from a program? We have already seen the syntax of the macro definition. Macro definition starts with the pseudo opcode macro and ends with the pseudo opcode mend. By checking or by looking for these pseudo opcodes, macro processor can recognize the macro definitions. And one more thing, macro processor has to recognize nested macros also, which means the last mend pseudo opcode has to match with the first macro pseudo opcode. Then the second task is saving the definitions. So whatever macro definitions are there in the source assembly language program, it has to be stored in the memory. before the macro expansion. Then the third step is recognizing macro calls. How can a macro processor recognize the macro calls? We know that what is the format of a macro call. Macro call starts with the macro name followed by the real arguments passing to the macro definition. So in the macro call, the name of the macro is treating as the opcode. That means the action to be performed. And the macro processor will recognize the macro calls that appear as the operation mnemonic. Here operation mnemonic is nothing but the name of your macro, the name of your macro. Okay, then the fourth step is expand macro calls and substitute arguments. That means wherever macro call is occurring, each macro call has to be substituted with the corresponding macro definition. And when we are expanding the macro, the real arguments passing in the macro call has to be substituted in the place of dummy arguments in the macro definitions. That's all the first step in the implementation, that is a statement of the problem, which is specifying the basic tasks of the macro processor. Then second step onwards, it is differing in each algorithm. So first we are going to see the two-pass algorithm for implementation of the macro processor. So in today's class, we'll concentrate on the two-pass macro processor algorithm. When we are implementing the macro processor using two passes, we have to assume few things. So what are the assumptions made in this particular implementation? We'll see that. First assumption is macro processor is functionally independent of the assembler. That means the macro processor is separate one and the assembler is separate one. Macro processor will expand the macros, and the output which can without any macros will be given as the input to the assembler. And here in this particular two-pass algorithm, we won't be able to implement macro calls or macro definitions within the macro definitions. So these are the assumptions we are made in the implementation of two-pass algorithm for the macro processor. Before entering into the next steps of the implementation, we have to know what are the basic functions in the pass 1 and what are the basic functions of pass 2. Basic functions of pass 1 means processing the macro definitions, and whereas pass 2 means processing macro calls and expand. So we'll see pass 1, how it is performing. In the pass 1, it will examine each line of your program and it checks for the each opcode. Opcode is nothing but the operation to be performed. And it will check the pseudo opcode macro and end, and which means it is a macro definition and the corresponding macro definition. If the macro processor see any particular macro definition with the pseudo opcode macro and amend, it will stored into the database called macro definition table. Then the program without a macro definition, that means macro definition already stored into the memory, that remaining program without a macro definition has to be stored into the secondary storage to use in the pass 2. Okay, then we will be using one more database, that is macro name table. It contains only the names of the macros used in the program. So these are the functions of pass 1. It is scans each line of the program for opcode, and if it see any particular macro definition, it will stored into the database called a macro definition table, and except a macro definition, what is the remaining source program? That remaining source program has to be stored in the secondary storage to use by the pass 2. Then whatever macro names we have used in the program, it has to be stored into the macro name table. Then what are the functions of pass 2? Pass 2 will check for the occurrence of the macro names. That is nothing but it will check for the macro calls, and for each macro call, it will takes the macro definition, corresponding macro definition, and it will substitute. So that is nothing but checking for the macro call and expanding the macro call with the corresponding macro expansion. So this is the basic, these are the basic functions of the pass 1 and pass 2. Now we are entering into the third step of our, second step of our implementation, that is specification of databases. Since here we are discussing about the two-pass algorithm, we are going to see what are the databases we are using in both pass 1 and pass 2. So the second step in the implementation of macro processor is specification of databases. We have to see both pass 1 as well as pass 2. So first we'll see pass 1. So what is the input to the pass 1? Input to the pass 1 is your source program, which contains the macro definitions and macro calls. And what will be the output of the pass 1? Output of the pass 1 will be the input to your pass 2. Then here comes the real databases using in the pass 1. First one is the MDT. MDT means macro definition table. Macro definition table is using to store the body of your macro definition. Then the next one is the macro name table. It is used to store the names of the macros defined in your program. Then the next one is the macro definition table counter, which means it indicates the next available entry in your macro definition table. That means macro definition table is containing the definition, and the macro definition table counter is telling what is the next available entry to store your macro definition. That will be indicating by your macro definition table counter. Then the next one is the macro name table counter. That means again, what is the next available entry to store the macro name in the macro name table will be given by macro name table counter. Then the last one is, that is very important, argument list array. Argument list array means it is used to substitute the dummy arguments with the real arguments. That means when we are defining the macro, we will be using dummy arguments, but when we are calling the macro, we will pass the real arguments. So in this case of in the first pass 1, argument list array will be storing dummy arguments in the macro definition, dummy arguments in the argument list array in terms of the index markers. That means, I'll repeat, if we are storing macro definition into the memory, the dummy arguments mentioned in the macro definition will be storing as index markers. That we will see in detail in the next step. That is the purpose of the argument list array database in the pass 1. It will store dummy arguments in the terms of index markers in pass 1. I'll repeat again. So the pass 1, we are talking about the databases using in the pass 1. Basically, the input will be program the program with macro definitions and macro calls. Output will be the input to the pass 2, and the databases using our macro definition table to store the definitions, macro name table to store the macro names, macro definition table counter to indicate what is the next available entry to store the next definition. Macro name table is indicating what is the next available entry in the MNT to store the next macro name. Then argument list array to store index markers for your dummy arguments and the macro definition. Now we are going to see what are the databases using in the pass 2. As usual, the input to the pass 2 will be the output from pass 1, and the output of the pass 2 will be your expanded code, which means it will not contain any of your macros. Then here we will be using MDT and MNT, which has been created in pass 1. That is nothing but MDT is nothing but macro definition table. It is containing the macro definition. MNT is the macro name table. It is containing the macro names. Then apart from these two, we are using one more database, that is macro definition table pointer. That means when we are expanding the macro, we have to fetch each instruction from the macro definition body, right? So macro definition table pointer indicate the next line of text to be used during the macro expansion. Then the next one is the arithmetic log, sorry, argument logic. Sorry, next one is the argument list array. In the pass one, it will be using to represent dummy arguments in the terms of index markers. In the pass two, it will be using to substitute the real arguments value in the place of your index markers. It will be clear in the when we are discussing the next step. So these are the databases using in the pass 2. So in the pass 2, input will be the output of pass 1 and output will be the expanded code without any macros. And here we will be using the copy of the MDT and MNT created in pass 1. Apart from this, we will be using MDTP, that is the macro definition table pointer. It indicates the next line of text to be used in the macro expansion. Then here we will be using ALA, but the purpose of the ALA in second pass is different. Here in the second pass, ALA is using to substitute the value of index markers with the real arguments value. That is all about the second step. So we have seen first step, that is statement of the problem. Second step, we are second step onwards, it will vary for two pass algorithm as well as one pass algorithm. Here we are discussing about two pass algorithm. So for two pass algorithm, we have seen what are the specification of databases in both pass 1 and pass 2. Now we are moving on to the third step, that is nothing but specification of database format. We have to define the structure of the databases used in both pass 1 and pass 2. Here we need to study only about the main three databases, that is argument list array, macro definition table MDT and macro name table MNT. So first we'll see argument list array. It is very important. Argument list array will be using in both pass 1 and pass 2. But the purpose of ALA in pass 1 and pass 2 will be different. So first we'll see what is the structure of your ALA in the pass 1. You can see the example here. In this example, on the left side, I have a macro definition. Here, as usual, macro pseudo opcode indicates this is the beginning of your macro definition. And here we have the name of the macro as INCR. Apart from that, we have 4 dummy values. Loop 1 is a dummy label statement. And here arg1, arg2, arg3 are 3 dummy arguments. And here we have macro instructions. Then here we have mn pseudo opcode, which is indicating end of your macro definition. When we are storing this macro definition into the argument list array, it is using to replace these dummy values with the index markers. Index markers will start with the hash symbol. So what are the dummy values in this macro definition? Loop 1, arg1, arg2, arg3. So the respective index markers will be hash 0 for loop 1, hash 1 for arg1, hash 2 for arg3, hash 3 for, sorry, hash 2 for arg2 and hash 3 for arg3. So the purpose of argument list array database in pass 1 is substitute all the dummy arguments with the index markers, whereas index markers are starting with the hash symbol. Now we'll see what is the purpose of the ALA in pass 2. Suppose we have a macro call like this. What is a macro call? I have mentioned here: loop 1 incr data 1 data 2 data 3. So incr is the name of the macro, and the real arguments we are passing here are data 1 data 2 data 3, and the real loop name what we are going to pass here is loop 1. We have already stored the index markers for these real arguments in the pass one. That is, for index marker for the loop 1 is hash 0, and index marker for data 1 is hash 1, index marker for data 2 is hash 2, index marker for data 3 is hash 3. Now, what is the real value of these index marker? That will be that will come to know at the time of the macro call. The real macro argument value, you can place it in the index marker place. So the index value 0 will be, the real value will be loop 1, and the index marker value 1 will be data 1. The index marker 2, the real value will be data 2, and the index marker 3 value will be data 3 for this corresponding macro call. So we were discussing about the first database, that is argument list array. Mainly it is using to maintain the details about the parameters or the arguments. Here parameters or the arguments, and it is maintaining the details about the parameters also. Here we have seen in the first pass, it will be storing index markers for the dummy arguments, and in the second pass, it will place the real values in the index marker place at the time of macro call. Then the second important database, sorry, in the second important database is macro definition table. Macro definition table means what? It is used to store the all the macro definitions in your source program, and the size for macro definition is 80 bytes per entry, which means for each macro definition we have reserved 80 bytes memory. Here we have seen how can we recognize the macro definition by using the pseudo opcode macro and end. When we are storing macro definition into the macro definition table, we can skip the pseudo opcode macro. The remaining lines only we will be storing in the macro definition table. Now you can see the structure of the macro definition table here. On the left side, we have index values to give the numbers, and here we have the right side, the definition. Card indicates the program which is containing the macro definition. So here it is not lab, it is actually loop 1 and ampersand incr arg1 arg2 arg3, and there onwards we are storing. And when we are storing into the macro definition table, each dummy argument, the first one is ampersand loop 1, it has to be replaced by index markers as 0, and arg1 will be replaced by index marker hash 1, arg2 will be replaced by index marker hash 2, arg3 will be replaced by hash 3, and mn has to be there to indicate this is the end of your macro definition. So we are talking about the second database, macro definition table. It tells us what is the structure of the macro definitions table. It is using to store the macro definition, and the size of the macro definition is 80 bytes per entry. When we are storing the macro definition, no need to store the pseudo opcode macro. The remaining lines only we need to store. We need to store, and when we are storing also, the dummy arguments has to be replaced by index markers. Then the last database, that is macro name table. It is storing all the macro names, and it gives where is the expansion of the macro, particular macro name. So what is the size of the macro name table? It is 12 bytes. We'll see the structure first. This is the macro name table. First is the index value, and the second is the name of your macro, and we are reserving 8 bytes for the macro name. And here where we can see in which index position we can see the macro definition of this particular macro INCR in the MDT is giving by this value. So here MDT index tells us in which index position of MDT we can see the definition of INCR. For that we are reserving 4 bytes. So together we have 12 bytes per entry for each macro name entry in the macro name table. So we were talking about the last database, that is nothing but a macro name table. It is used to store all the macro names, and for each macro name entry we are reserving 12 bytes, 4 bytes for MDT index and 8 bytes for the macro name. MDT index means the index value of the MDT, where we can see the definition of your macro. That's all today's class, and will conclude our today's class. We were discussing about the implementation of the macro processor. We have seen what is a macro processor. It will expand our program and it will generate a program without any macros. And we have seen what are the steps in that. First, we have specified the problems, that is understanding what are the tasks to be performed by the macro processor. Then second step is what all databases we are used, we have to specify in both pass 1 and pass 2, because in the today's class we were discussing about 2-pass algorithm. After that, specification of the database format, that means what is the structure of the database. Then in the next class we are going to study about 2-pass algorithm as well as 1-pass algorithm. We have seen the main important databases are MDT, MNT and ALA. Thank you. Thanks for watching.